Don't worry, if you have anything to say, you can say by chatting. Don't think that it is silent. I'm just waiting for others to join. That's it. If you have any doubt in between that I'm teaching or not, you can message me, you can chat me in that. You can chat with me, or else you can directly ask by switching on your microphone. Gokul, you can directly ask me by switching on your microphone, because I may not understand your question here. You can ask me here. Gokul, are you there? Yeah, so far only 3 members joined. I don't know what happened this time. Many people are still yet to come, and one left. Shall we start the class? Because we can't wait till 7:30, right? Of course. Already we have waited much time. It's 9 minutes. So I'll be starting the class now. So I hope, see now, I think I can't see your messages as I am teaching in PowerPoint presentation. Whenever I ask some question, please respond by switching on your microphone. You can directly tell me. So I hope you can see the presentation slide. Okay. Yeah. So I have been teaching about Mohr circle in the last few classes, and today we are going to solve one of the problems which is related to the shear strength. So for that you need to know the concept of Mohr circle. Anyway, see, whenever as and when the Mohr circle concept is required, I always try to repeat the concept of Mohr circle because it's very difficult as well as very easy too. So if you know the concept, it is very easy. I'm just repeating briefly this time as I have already taught 2-3 times. So these are interrelated, Mohr circle and shear strength. Okay. Okay. Now y-axis we take shear stress or shear strength, which can be denoted by S. Okay, both are same, shear strength. And what is x-axis? X-axis is normal stress, which is denoted by sigma. Anyway, to simply make you understand, taking a block which is on the surface, any surface, okay. Now we are applying some normal load, right here. Now you want to push in this direction. When there is a normal load present on this block, you are pushing in this direction, you are applying, okay. There is a man who is applying the force. Now if you observe, if there is a more normal load, if normal load is subject, it is increasing, that means you are pressing the block in vertical direction, pressing in this direction. At that time you need more strength or more pressure, more load in this direction to move the block. So that means the strength of this block in this direction is function of the normal load. Okay, if it is increasing, the strength in this direction also will increase. In the same way, if it is shear is what, where is the shear happening? In between the block and surface. So in our school life we have already studied that here the force required to move this block, the minimum force required to move this block is mu into n. What is mu? It is a frictional coefficient between the block and surface. If you know the coefficient, let us maybe 0.3 like that. If you know the normal load what is applied, you can find out how much force is required, minimum. Okay, if n is increasing, F will also increase. In the same way, here when soil is subjected to normal load, okay, there is a soil subjected to normal load, then you need more shearing stress to fail this soil. So before telling about this shear strength, I want to tell you that the soil will always fail in shear. Soil always fails in shear. Okay, remember this. It cannot fail in compression. Okay, it can fail in tension load and under compression load. Just a minute, I'll put my mobile in silent mode. Yeah. Here, soil always fails in shear. Though you are applying compression load, though you are applying tensile load, any load, it doesn't matter, it fails in shear. So it people may say that soil failed under tension. Yes, it failed under tension load, but the failure plane is subjected to the shearing. That is how the soil will fail. See what happens for the soil to fail. Let us take at this place. Okay, for the soil to fail, what has to happen? This all soil grains should move one over another, right? It should move one over another. So when these all particles are moving one over another, there is a plane. Suppose this is a block of soil, okay, then because of this there can be a failure plane like this, which is due to the shearing between the soil particles. So remember that soil always fails in shear. Now so whenever there is a normal load, there will be more shear strength existing in the shear strength. Now that is how we are relating shear stress or shear strength with normal stress in this quadrant. Okay, now coming to Mohr circle, I have already told you the concept of Mohr circle. Okay, we always take half of the circle, which is called Mohr circle, to represent the. I told you the formation of the Mohr circle. How does it happen? See, every point on the Mohr circle, is the stress combination. Suppose you take at this point, what is this? There is some normal stress and there is some shear stress. It represents a plane in a block. Suppose you take a block of soil, so you are just applying some load. Let us say you are applying some load from all over. Okay, then what happens? This soil block has infinite number of planes, right? Whenever you are applying this kind of some load, any kind of load, each plane is subjected to one normal load, okay, one shear load, like this. Each plane is subjected to one normal load, and so if you take all those points on different planes, then if you draw, then you will get this Mohr circle. So coming to here normal stress is there, but tau is 0. Okay, sigma comma, let us say some sigma 1 comma 0, and here you can say sigma, let us say sigma 3. Why sigma 1, sigma 3, I will tell you later. But let us say some value sigma here, and here also it is 0, tau is 0. That means this, the plane on which there is no shear stress but there is only normal stress. Here also there is only normal stress but there is no shear stress. Those planes are called major principal. See, this is major principal plane, this is minor principal plane. Both are principal planes, but the plane which is having more normal stress along with 0 shear stress is called major principal, and the plane which has minimum normal stress along with 0 shear stress is called minor principal stress or principal plane on which it is acting. Okay, minor principal stress on which it is acting called plane. In the way it is major. Okay, this is how Mohr circle. Now every soil has one failure envelope. So let us move to the next slide. Then anyway, so take any soil. The soil has a particular strength, right? This soil will have some strength. Okay, but that strength varies. That shear, see, strength always means, you should remember, shear strength. Some shear strength it always has. So but it is function of normal stress. Sorry, it is function of normal stress. Now as we take normal stress versus shear stress. So I told you there is a failure envelope, okay, which is a straight line, okay, which is a straight line. This is C plus sigma tan pi, okay, I'll write here C plus sigma tan phi. What is S? S is shear strength, or tau you can write, and sigma is normal stress. C is the cohesion, whereas phi is friction angle, right? Friction angle. These two are shear strength parameters, okay. Now this is C, the intercept is C, and the angle is inclined with x-axis is friction angle. Now this is the failure envelope, okay, or failure curve, failure line for a soil, okay. If you apply this much sigma, then you will have this much shear strength. If you apply this much sigma, you will have this much shear strength. Now coming to the Mohr circle, we will draw the Mohr circle in the same plane, same sigma tau plane. This is sigma tau plane, okay. We will draw the Mohr circle. Suppose now I am taking a soil sample, random soil sample whose failure envelope is like this. Now I am applying some random loads or stresses all around the soil sample. Now this is soil sample whose failure envelope is here. See, it doesn't fail when the when you are applying low loads, small loads, okay, generally. So it is not failing, let us say. At that time also every plane has some shear stress and some normal stress, because you are applying some loads. They may be small, but they are some loads, because of which every plane has some load, some normal stress and some shear stress. Now for corresponding to that small load, I will draw a Mohr circle here, because see, now this Mohr circle does not having many number of points, many number of planes. None of the points is reaching this failure envelope. They are well below this failure envelope. That is the reason why for these loads which are causing these stresses, it will not fail. So as you are increasing this load, what happens? The stresses on the soil sample also will increase. So those soil sample, suppose you are changing both, then what happens? Stresses will increase like that. So like that, at one point this Mohr circle will touch this failure envelope. Okay, let me delete. Okay, but those are just make you to understand. Now, sorry. Now let us say Mohr circle has reached this failure envelope, but see, all points, there are infinite points on this circle, but if you say infinite minus 1, it is also infinite, but for the time being infinite is, let us say it is a particular number, okay, 1 crore, let us say 1 crore points are there on this circle. 1 crore points minus 1 points are not touching this, because this touches only at one point, only one point. Remaining all points are well below the failure envelope. Okay, that one point represents one plane. Okay, suppose you are applying, okay, at one particular plane, that stresses will be there, okay, that normal stress, okay, that normal stress sigma f, and that shear stress tau f, okay, tau f sigma f. Only along that plane this slippage will occur. That means this part of the block will move down, this part of the block will move up, and finally this total block will fail because of the shear happens along this plane. Along this plane, what are the stresses? These are the stresses. Remaining all planes will be safer, but one plane is subjected to fail, matlab total soil block is getting failed, right? That is how the concept of the Moore circle. Now you understood. Now let us enter into some formulations. We will derive some formulas. Okay. Now just give me a minute. I'll be back. Okay. Right. There are very less number of audience today. Anyway, so moving to we'll derive some formulas out of it. See, generally there are some laboratory tests on soil to find CI and 5, which are strength parameters. Okay, strength parameters. So one of them is triaxial test. Okay, one of them is triaxial test. Okay, there are different types of triaxial tests are available: CU, UU, CD, like that. There are 3 tests available. One is consolidated undrained, unconsolidated undrained. This will come to later. We'll come to this part later. Anyway, so now just to give you a brief, so there is a triaxial test setup like this, taking a soil sample which is in the cylinder shape. Okay, now this is enclosed in a chamber, circular cylinder, which is filled by water completely. Okay, which is filled by completely water. Now this water gives equal pressure from all the sides of this circular sample. Okay, now this circular sample is also subjected to one vertical load. Okay, that is called deviatoric stress. Deviatoric stress or deviatoric load, and this will give the water which is inside this cell is giving some pressure, that is called cell pressure. Okay, so cell pressure and deviatoric stress, there are 2 things which will be applied on this soil sample. Now when you continuously apply this cell pressure, then after deviatoric stress, at one point this soil will fail. When the soil fails from the cell pressure and deviatoric stresses, we will find out what is C, what is phi. Okay, now let us see in the magnified figure. Okay, now this is a soil sample which is inside this one. Now initially only cell pressure is there, let us say pressure is there. Okay, see, cell pressure is denoted by sigma 2 or sigma 3, but we take sigma 3 always because, see, let us take a block. Okay, let us take a block. Let us say this is sigma 1. Okay, and this is sigma 2 and this is sigma 3. Here what do we do? here this water is applying the pressure around the in the horizontal plane. You can say in the horizontal plane it is applying equally. Of course in the vertical plane also, if you see, all around the water is applying the same pressure. Now after applying the cell pressure which is due to the water, what are we doing? We are applying the deviatoric stress. This is what the triaxial test it is. You will apply deviatoric stress only in vertical direction. At that time what is happening? In the horizontal direction, sigma 2 and sigma 3 means all around they are same, only this vertical pressure is changing, right? That is the reason why sigma 2 equal to sigma 3 we take, and we denote it by only sigma 3. Okay, that is how, because sigma 2 equal to sigma 3 all around, we'll just denote it by sigma 3. That's it. Now this vertical pressure is denoted by sigma 1, right? Now let us give sigma 3 due to cell pressure. Cell pressure is always called as sigma 3, always denoted by. But is this sigma 3 is also acting from the top? Okay, right or not? Because of the water all around. Along with that, deviatoric stress, which is denoted by sigma d, is also coming vertically, due to which soil fails. With just cell pressure, it will not fail because it is applied all around. The soil will fail only when there is different pressure in the different direction. So that is the reason why we are applying deviatoric stress. Okay, so now extra we are applying deviatoric stress, sigma 3 plus sigma d. This equal to sigma 1. That is called vertical pressure here. Now there are two different pressures. One is horizontal pressure sigma 3, vertical pressure sigma 1, which is the sum of sigma 3 and deviatoric stress. Now if you see, are we applying any shear stresses? No, we are not applying any shear stresses along these planes. That is the reason why in the triaxial test these are called principal stresses. This is called minor principal stress, this is called major principal stress. Why? This is more because additionally we are applying sigma d. That is the reason why this is called major principal stress, and this plane is called major principal plane because the plane on which it is acting is called plane, major principal plane, and this is called minor principal stress. Why? There is no shear stress on this also. That is the reason why. And this plane is called minor principal plane. So that's how. Now whenever you are given in the question cell pressure, that is called sigma 3. Whenever you are given deviatoric stress, you can't take just sigma d. You have to add to the sigma 3 which is given. Then you will get the major principal stress. Now going to the again more circle plane. Okay, now now you applied some cell pressure which is constant over the test, and you are continuously applying some sigma d. Okay, you are slowly increasing. At one point what happens? The soil will fail. So at that point, whatever is sigma 3 and whatever is sigma 1, okay, they are, let us say we are taking as like this. Okay, sigma 1f, sigma 3f. Okay, now so a more circle. So what are these points? These points are referring the principal planes. Means this stress is major principal stress, comma tau 0. This is minor principal stress, comma 0, because tau is 0. Okay, now here of course sigma 1f, right? And what is this? Sigma 3f, comma 0, right? Why? Because they are principal stresses. Also tau is 0. So you can take any plane and you can draw this more circle. Now what I am taking, I am taking two planes to draw the Mohr circle. I have already told in the previous classes, to draw a Mohr circle you need two stresses on two different planes which are perpendicular to each other. Now this plane and this plane are perpendicular to each other. I am taking two stresses, okay, normal stress and shear stress, sigma 3 comma 0, sigma 1 comma 0. So I am drawing a Mohr circle. Now I am noting down these 2 points, then I am making a circle out of it. That's it. This is called Mohr circle, and these are the stresses at failure. That is the reason why this will definitely touch failure envelope. So let us consider this is C5 soil, okay, C5 soil, okay. What is C5 soil? The soil which has cohesion as well as some friction. Both those are called C5 soils, okay. Now some soils can be having only cohesion but not friction. Those are called cohesive soil, okay, only cohesion only. Those are called cohesive soils. What is the example? Clay. And cohesion less soils are called when there is no cohesion, only friction angle, only friction only, means C is 0. Those are generally sands, okay. Sands will not have cohesion, okay, they only have strength due to the friction between the particles, okay. So that's how. If a soil is having both cohesion and friction, those are called C5 soils. Generally silty soil or silty sand, like that, they are C5 soils. Now for them, so we will consider the failure envelope like that, okay. What I am doing, I'll just draw a failure envelope such that, okay, it touches, okay, let us say it is touching at this point, okay. Now this is failure envelope, okay. And what is this? We know this is friction angle, this angle, and this is denoted by phi, and this is nothing but friction angle. And what is this? This is cohesion, C. Now just tell me, suppose this is the center, I am telling this as O, let us say. Now if I draw a line, okay, so can you tell me what is this angle? One of you, can you tell me? Can you tell me what is that angle? I can't hear anyone's voice, nobody is responding. Gokul, Likita, Naresh, can one of you? Manabendra, Srijan. Okay, I will only tell, but at least can you hear? I am having a doubt that you are unable to hear. Can somebody reply at least? Can you hear? Yeah, okay, fine. So anyway, so of course this is what? This is tangent to the circle. So taking tangent and drawing a line between the center to the point of interaction between the tangent and circle, it is perpendicular always. That means this is perpendicular, okay. This much you should remember. Now so out of this I just want to sorry okay. Okay, I am extending this line, just that, and let us say this is A and this point of intersection is B. So now if this is phi, this is also phi, of course, because I'm just extending. Okay, now what do I do? From the triangle AOB, from the triangle AOB, what can I write? Can you tell me cot pi at least? What is cot pi? This much you should reply, I feel. What is cot pi? Not that, from this triangle, using the sides. This is right angle. Now tell me. Or at least tell me if this is C, cohesion, okay, and this is let us say this is cohesion, and I give this point as, let us say I am denoting it by some S, okay, this point is S and this length is C. Now can you tell me from this triangle, from the triangle AS, let us say AST, this point is T. Now from the triangle AST, can you tell me what is cot pi?
Yes, sir. AS by TS.
Cot pi is AS by TS. Okay?
Yes, sir.
Okay, fine. Now what is AS here? AS is unknown. But we know what is TS, that is C, cohesion. Okay? Now AS is equal to C cot pi. Okay? Now this distance is, I know in terms of cohesion and friction angle, that is C cot pi, whereas C is cohesion, cot pi, pi is friction angle. Now this, I know this distance. Can one of you tell me what is the distance between S and O in terms of this sigma 1f or sigma 3f? I am asking what is SO. Can you tell me, one of you, what is the distance? You know up to here sigma 3f. You know up to this.
Sigma 1 plus sigma 3 divided by 2.
Okay, F. Okay, for the timing I don't write F suffix. Okay, this distance is nothing but it's a midpoint between these two. Suppose this is 2, this is 4, this will be 3, which is nothing but 2 plus 4 by 2, 3. In the same way, sigma 3 plus sigma 1 by 2 will be the distance between this and this. Now you know what is SO, you know what is AS, C cot pi. Now can someone tell me what is this OB? Now you know AS and SO. I just want to know what is BO in terms of sigma 1 and sigma 3. If you can tell me, that will be very nice. Can you tell me? At least what is this equal to? This BO, what is this? If, what is the distance between sigma 1 and sigma f? This is diameter of the circle. Okay, because this is semicircle, this will be diameter. Then what is this? If from this point to this point, if it is diameter, what will be this? Radius. And what about OB? What about OB? Is OB radius? Is OB radius? Yes or no? Why it is radius? Can one of you tell me?
See, the two point of view distance are same. That's why it becomes radius.
Radius is the distance between center to any point on the circle. Okay, I am taking distance between any point on the circle and the center, that is why it is radius, and this are equal to each other, right? Now if you can tell me what is the distance between these two, then I can divide by 2 so that I will get the radius. That radius is nothing but OB. Now tell me what is the distance between these 2 points. Somebody told me distance between S and O, this, right? But what is the distance between these two? Suppose this is 4, 0 and this is 2, 0. What is the distance between these 2 points? You should reply. This is how the interaction is. No one? This is 4, 0 and this is 2, 0. Then what is the distance between these 2 points? I expect at least one of you to reply. Manabendra, you want to tell? 2. See, I told you don't write in the chat box. I think Gokul, I don't know. I think Gokul can't. I mean, his mic is not working. That's okay for Gokul. But other people don't write. You have to tell me. Yes, it's 2. 2. How did you get 2? It's sigma 1 minus sigma 3. 4 minus 2. That's it. The distance between these 2 points is sigma 1 minus sigma 3. Then what is the radius? Sigma 1 minus sigma 3 by 2. So that is nothing but OB. OB is also radius. So sigma 1 minus sigma 3 by 2. Right? Now, you know what is SO. You know what is AS, C cot pi. You know what is OB. Right? And this is a right angle triangle. What is right angle triangle? AOB. AOB is a right angle triangle. Now, tell me, I want to know what is, I want to know what is sin pi from this big triangle AOB. What is sin pi? Can somebody tell me from this triangle? You should reply. It should not be like this. I am telling you. These are basic 7th class, 8th class, maybe 6th class also. I don't know. I don't remember. But it is definitely below 10th class. And you are in engineering and you have completed already. Some of you. Sin phi, you should develop this habit of replying and telling the answers. OB by AS. And Likita, your microphone is not working? I hope your microphone is working. No? What happened? I don't know. Anyway, OB by AS. OB by AS. Is it AS?
No, sir, AO.
Exactly. OB by AO. Okay. Now you know OB in terms of OB nothing but BO. OB in terms of sigma 1 and sigma 3. Also AO. AO is also in terms of sigma 1 and sigma 3 and phi, because you know AS and you know SO, nothing but OB by AS plus SO, right? So I'll write this formula in the next slide directly. Cos OB by AS plus SO. And what is OB? It's a radius. Okay, I'll OB is radius. What is radius? Sigma 1 minus sigma 3 by 2. What is AS? AS is C cot pi, right? Plus what is SO? SO is sigma 1 plus sigma 3 by 2, right? This is what? C cot pi is AS and SO is sigma 1 plus sigma 3 by 2 and OB is sigma 1 minus sigma 3 by 2. So I have written in terms of this. Now what I want to do, cos pi equal to sigma 1 minus sigma 3. I'll take this 2 down, then and I'll multiply with these terms, then 2c cot pi plus 2 will be cancelled here, then sigma 1 plus sigma 3 is left, right? Now let us take this to this side and writing sigma 1 minus sigma 3 on LH side, then multiply 2c cot pi into cos pi will be is it cos pi or sin pi? Sorry, sin pi. That is what you are not correcting me, you are just blindly following. Now tell me, sin phi into cot pi, what will be remaining? If I multiply sin phi with cot pi, what will be remaining? Because I am multiplying these two, I have taken this denominator to this side. Nobody is typing even. Cot pi is cos pi by sin phi cancel, then you will be getting cos phi plus this sin phi is again multiplied to this sigma 1 plus sigma 3 into sin phi, right? Now what do? We will take sigma 1 terms one side, sigma 3 terms one side. Let us take this sigma 1 term this side. What happens? Sigma 1 is sigma 1, then sigma 1 sin phi will be taken left side, whereas 2c cos phi is kept just like that, and sigma 3 sin phi is this side, whereas sigma 3 is coming this side, okay, like this, right? Now just take this common, then 2c cos phi plus sigma 3 1 plus sin phi, right? Now what happens in the next step? In the next step I will take this term to this side, okay, then sigma 1 I will write only sigma 1 in the next slide, then I will write this term first, sigma 3 term first, sigma 3 1 plus sin phi by this has come down, so 1 minus sin phi plus 2c cos phi divided by 1 minus sin phi, right? So I hope you can see the slide. Can you confirm, one of you? Can you see the slide? Yeah, fine. Anyway, now after coming here, this here I can write this sigma 3 tan square 45 plus I don't know what happened, anyway,
Hi, by 2.
yeah, okay, this one plus I'll write 2c first, and this cos phi by sin phi can be written as tan, okay, right? Now here, yeah, I will solve. See here, since 1 plus sin phi by 1 minus sin phi equal to tan square 45 plus phi by 2, and cos phi by 1 minus sin phi equal to tan 45 plus phi by 2. Because of these two I just taken like this. Now what can I do here? I'll just keep it like this as it is, sigma 1 equal to sigma tan square, let us write it as alpha, let us say tan square or alpha, this one sorry, this one is alpha, plus 2c tan alpha, right, where alpha is 45 plus pi by 2. So this is the derivation. Now I will derive these two also, but I will derive these two in the next class. Before that we will solve one problem in this class. Okay, so coming to the problem, I don't know what happens to this suddenly. Let me close this and open. See that we have lost that, but I'll directly write this formula. Okay, what did we get? Sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha.
Hello, sir.
Tell me. Okay,
Don't see this right.
yeah, okay, let me check. Can you see now? I hope you can see now.
Yes, sir.
Yeah, so this is the formula which we derived, sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha, where alpha equal to 45 plus pi by 2, right? Now see, we will solve this problem now. Solution. So in a triaxial unconsolidated undrained test, UU test, okay, you can read about what are the different types of tests. Okay, but anyway, now coming to the problem, you test on the saturated clay sample, the cell pressure was 100 kPa. What was the cell pressure denoted by sigma 3 is 100 kPa. If the deviatoric stress at failure is 150, deviatoric stress means sigma d is 150, then undrained shear strength of the soil is, see now it is given as clay sample. Okay, clay means what? Friction angle will be 0. Okay, if friction angle is 0, what is phi? Tell me somebody.
Sir,
Sea
sea soil.
soil.
Clay soil means sea soil.
Yeah, okay, clay is sea soil, clay is having only cohesion, that means friction angle 0, then alpha equal to 45 degrees, right? Now we know sigma d. What is sigma 1 then? I told you sigma 1 is sigma 3 plus sigma d, 100 plus 150 is 250. You know sigma 3, you know sigma 1, you know alpha. Can you substitute that? 250 equal to 100 tan square 45 degrees, because alpha is 45, plus 2c tan 45. Tan 45 is 1 plus 2c into 1 equal to 250. Can somebody solve and tell me what is c value from this? One point? How? Okay. Yeah. You can take time. How much time do you take? I don't understand. Huh? 75. And if you see the question is in kPa. All are in kPa. Sigma 1 is in kPa, sigma 3 is in kPa. Then you will be getting C in kPa. Cohesion is 75 and friction angle is 0. Okay, then how the Mohr circle will be? How the failure envelope will be? It will be horizontal because friction angle is 0. There is no friction angle here, and C itself is 75. What is the underlying shear strength? C plus sigma tan pi. Let us say this is a failure envelope. Shear strength equal to sigma C plus. If we talk about effective parameters, C dash phi dash you can write, and here phi dash is 0 because it is clay, and then S equal to C, and shear strength, underlying shear strength will be equal to 75. So answer is 75 kPa. Okay, 75 kPa. That is how you have to calculate. So is there any doubt in this problem? And I told you I will derive, actually I will derive this again here. Just to keep note of sigma 1 minus, then where did we approach? I'll just it is deleted, 2c cos phi by 1 minus sin phi plus sigma 3 1 plus sin phi by 1 minus sin phi, right? So it was deleted, again I am writing for your. So sigma 3 I will write, then tan square 45 plus phi by 2, this can be written as, whereas 2c cos phi by sin phi can be written as tan 45 plus by 2, whereas this square will be there, here square will not be there, that's it. Okay, now these derivations, 1 plus sin pi by 1 minus sin pi equal to this derivation I will do in the next class. This is equal to this. These derivations I will be doing in the next class. Okay, now I hope it is understood. If you have any doubt, you can tell me.
Can I get the video of the tutorial, please?
Yeah, you can get. I'll be sending to authority. They will be uploading. Okay.
Sir, they are not sending the.
Yeah. Actually, we are also facing some problem in sending them. Now, this week we will be sending to them. Okay. Actually, there is something wrong with my presentation or laptop. I hope while giving the lecture, it was understood. Okay. Now it is clumsy. Okay, but don't worry.
Will you upload the video on your YouTube site?
Yeah. Okay. I'll check that. Okay. So I hope you have understood. Is there any doubt?
This part,
Which part?
essentially with serious plus phi tan phi.
I told you, right? This one. Anyway, I explained this. There is some problem here. I'll close this and I'll open and share with you. Tell me which part.
Sir, I will not see the.
Yes. I told you, right? See, there is a Morse envelope. Failure envelope, whose, see, this is a straight line, let us say, and this is C, and the friction angle is angle is phi. Okay, then how do you write this equation of this line? Y equal to mx plus c, right?
Yes, sir.
What is y here? Shear strength.
Yes, sir. Yes.
And what is m? If the angle is phi, tan phi. Slope. What is x here? Sigma. What is the constant here? Intercept. Cohesion. S equal to C plus sigma tan phi. This is the shear strength formula. Okay, understood? So this is how. Then in this, if the phi value is 0, then what is the value of shear strength? S equal to C directly,
Yes, sir.
right? That is what called undrained shear strength. Okay, right. Yeah. So I hope there is no doubt. So shall I close the session now?
Yes, sir.
I'm closing the session. Thank you guys.